Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. This is part 3 video on the chapter of squares and square roots. In this video, I will discuss about how to find the square of a number. That is, how do we all the shortcut methods of squaring a number, and the numbers will usually be of 2-digit numbers, and some methods will also work for 3 digits or 4-digit numbers. And we will also see some interesting patterns in finding the square of some certain numbers. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes prepared on the left hand side, and on the right hand side I will do the discussion and the solving of any example problems. Now I will provide a link to the PDF of my quick notes in the description below, so you can have my notes from that link. So you need not take any screenshot from my notes, but while I am discussing and solving the problems, you please do take any notes wherever you think it is necessary. Okay, so in this video we will learn how do we find the square of a number. Usually we will mostly we will consider 2-digit numbers, and for some methods it will also work for more than 2-digit numbers. So the first method is the column method. This works for a 2-digit number. So let's say if the 2-digit number is of the form AB, where B is the digit at the units place and A is the digit in the tens place, then how do we find AB square? So we have to find a 2-digit number. We are given 2-digit number. Let's say 2-digit number is AB. So this is the B is the digit in the units place and A is the digit at the tens place. So we have to find AB, this square. We have to square AB. Now we prepare in the column method. We prepare a table of 3 columns, and the first column, the first column, it will be, the heading will be A square. That is, we have to find the value of A square, where A is the digit at the tens place. And the second column will have the heading 2 into twice of A into B, and the third column will be B square. Now so inside below the A square column, the first column is A square. Below it you will write the value of A square. Now whatever that value is, A square, it could be of 1 digit, it could be of single digit, it could be of maximum 2 digits. So let's say A square is we are considering A square. Let's say it is of the form x9 and x10, where x9 and x10 are digits. Definitely x9 is not 0, and so x9 and x10 are one of the 10 digits. And okay, and twice of AB, whatever that value is, let that value is represented by as x3, x4 and x5, where x3, x4, x5 are also digits, one of the 10 digits. Now why so now twice of AB, now A and B are digits, so the maximum value of A and B can be 9. So 9 into 9, A and B, 9 into 9 will be 81, and 81 into 2 will be it will be a 3-digit number. So twice of AB can be a 3-digit number. That is the reason we are expressing twice of AB as x3, x4, x5, and B square will also be maximum 2-digit, and we are expressing the B square as x1 and x2. That is, the value of whatever the value of b squared is, that value has x2 as the digit at units place and x1 as the digit in the tens place. Similarly, for twice ab, whatever the value is, that value has x5 as the digit in the units place, x4 as the digit in the tens place, and x3 as the digit in the hundred place. Similarly, for a square, x10 is the digit in the tens units place and x9 is the digit in the tens place. So this we will write below each column, below the headings. Now, how we will find AB's whole square? So you can see in the notes on the left hand side, this x2, we are all the digits that will be considered in the final result are underlined or highlighted with a double underline. So x2 will be a part of the final result, this digit. Now first what we will do for b square, whatever the b square is, that is b square, if b square is of the form x1 x2, if x1, if it exists, that is if b square is two digit number, then only you add x1, that is the digit of b square at the tens place, you add x1 with the value of twice of ab. So you can see that the first step is we are adding twice of ab is in the form x3, x4 and x5. So we are if x1 b square, if x1 b square is a two digit number, then x1 will exist. So only if x1 exists, then we will add x1 with the value of twice ab, and twice ab has been written in the form x3, x4, x5. Anyway, now whatever after adding, let's say whatever the value is, that value is a three digit number. Let's say the digits are x6, x7 and x8. It could be maximum three digit number after adding x1 to the value of twice of ab. Now whatever this value is, so we are representing it with the digits, three digits, x6, x7, x8. We will need this x8. So I am highlighting it with double underline. Okay. Now whatever is left over, this is left over. So over here x1 for b square, x1 was left over. That is, we added x1 with the value of twice of ab. And after the addition, if the value is of three digit, then the digit at the units place, if it is x8, we will need that. Except the digits at the units place, whatever digit is remaining, that is x6, x7, we will add this with the value of a square. With the value of a square. So if a square is x9 and x10, we will just add x6, x7. And let's say this addition, this value will also be maximum two digit. So if this is x1 and x12, we will need both these digits. So the final result of AB whole square will be the number formed by the digits as x11, x12, x8 and x2. So this will be the square of the AB, value of the AB's whole square. Now in the notes you can see one example. This is a first example. I have tried my best to visually show what is happening. So there are some, so we can see the example of 96 square. We are squaring 96. So in the 96A, the digit at the tens place is A9 and the digits at the units place B is 6. So B square is 36, twice of AB is 108 and A square is 81. Now B square is 36, so we will add the digit of B square at tens place, which is 3, with the value of twice AB. So we are adding 108 plus 3 and the result is 111. So the digit 111, the digit at the units place is 1 and the remaining digits are 11. So we are adding then again 11 with the value of A square. So 81 plus 11 is 92. So hence the final value will be 929216. 92 is coming from the final addition value of the first column, and and 9 2, after 9 2, the 1 is coming from the final value of the second column, the digits at the unit place of the final value of the second column, and the last digit in the result is coming from the digit of the units place of the third column. Okay, there is another example like 83, 83 square. So since the notes will be you can the link of the notes will anyway be in the description. You can check that out. So for the sake of explanation, let me do a squaring of a number, of a two-digit number. Let's say we are doing as an example or as an exercise. Let's find the square. I'm taking an example from the. I will not be solving the exercise 3C from the textbook of author RS Aggarwal, because one thing is that I have not really understood the diagonal method of squaring a number. It is still not clear to me. Once it is clear, I will make a video on the diagonal method of squaring a number. So from the exercise 3C, let me solve the problems 1, 2, 3, 4, where we have to find the squaring of numbers using the column method. Okay. So 23 square. 23 square. So here we can see A is 2 and B is equal to 3. So you can quickly draw the table and the three columns. So the first column is A square, the second column is twice A into B, and the third column is B square. Now B square, B is 3, so B square will be 9, twice of AB will be 12, and A square, A is 2, so A square will be 4. A square will be 4. So what do? We can see, we start from the third column. We see that the B square is a single digit number, so we will require the digit at the units place. This is 9. Okay. So we do not have any digit in the tens place, so we did not add anything with the second column. Okay. Now, so you can do like this. You can consider there is a digit 0, even though this is weird. This will make no sense, but just for the sake of understanding, and if you can add. Even though this is redundant, you will add the 0 to 12. This is becoming 12. Now from the 12, I will need the digit at the units place in the final result, and whatever is left over 1, I will add 1 here. This one will be added with the 4. That is the first column, and I've got result as 5. So 5 has, so these digits I will require. So I can say 23 square will be the digits I got in the first column, that is 5, and the units digits from the second column, that is 2, and the digit at the unit place from the third column, which is 9. So I hope this is a correct value. Let me quickly check if 23 square is 529 is okay. This is fine, 529. So this was an example. Problem number 1 from exercise 3C. Exercise 3C, problem number 1. Let's solve all the problems. Exercise 3C, let's solve problem number 2, which is squaring of 35 square. We have to find 35 square. So over here we can see A equals to 3 and 5 is equal to not 5 but B is equal to 5. Okay. So we will make the table. We will make the table of the three columns, and we write the headings as A square. The first column is A square, the second column is twice of a into b, 2 into a into b, and the third column is b square. So what is b square? B is 5, so b square is 25. What is twice of AB? A into B is 15, so this is 30. And A square is 3, A square is 9. So B square, we see 25, it is a two-digit number. So we will need the digit at the units place. Underline, double underline, 5. And you have this digit left over. So you will add this digit with the second column, plus 2. And you get 32. I will need, from 32, I will need the digit at the units place, that is, I will need 2 in the final result. And what is left over is digit 3. I will add this 3 with the first column, and I get 12. In the first column, I get 12, I will need both the digits. And hence, now the result we can write it as the square of 35 will be all the digits from the first column, that is 1, 2, the units digits from the second column, that is 2, and the units digit from the third column, that is 5. So let me quickly check if this is correct or not. Yeah, it is fine. So 35 square is 122.5. Let me do, there is 52 square and 96 square. Okay, 96 square is already there in the notes. So I will do 52 square. So let's see, 50, this is problem number 3. We have to find 52 square. I hope you have got the idea, the basic concept, how we are finding this, how we are squaring a two-digit number using the column method. So over here, A is 5, B is 2. Okay. Now we create the table of the three columns. And you name the headings. First column is A square, second column is 2 into A into B, third column is B square. So what is B square? B is 2, so B square will be 4. Twice of A into B is 5 into 2, that is 10, so this is 20. And what is A square? A is 5, so this is 25. Now I will start from the third column. I see the third column, the B square value is a single digit number. So I will require the digits at the units place. I am marking it, highlighting it with double underline. Now, since there is no digit in the tens place, we need not add anything with the second column. So now we see, you can simply say this is nothing to be added, plus 0, and I got 20. Now in the 20, I will need the digits at the units place. This one I will need in the final result. So what is left over is 2. I will then add 2 with the first column. And I get result 27. From 27, actually you can say I will need both the digits from the first column. So the value of 52 or squaring of 52 becomes 27, that is the entire value from the result from the first column, and then the units digit from the second column 0, and then the units digit from the third column, that is 4. So 52 whole square is 2704. Let me quickly check if this is correct or not. Yes, this is correct. Okay. So I hope you understood the column method for squaring a two-digit number. Okay. Now let's understand the second method of squaring a two-digit number using the formula a plus b. Sorry, in the notes it should be a plus b whole square. You know the formula, algebraic identity, that a plus b whole square is a square plus twice of ab plus b square. Now if you are given a two-digit number, let's say if you are given a two-digit number is, let's say, x and y, that is x is a digit and y is a digit. X is the digit at the tens place and y is the digit at the units place. Now, how do we find xy, this number, square? How do we square it? Find the value of the square. So xy can be written as if I expand the number xy, it will be 10 into x plus y. So you have studied in your previous class or class 7 or class 6 how to expand given number in the with the expand using the powers of 10. So xy, we are two-digit number xy, where x is the digit at the tens place and y is the digit at the units place. When expanded, will be of the form 10x plus y. So we have 10x plus y whole square. So I have got now a plus b whole square form. If I apply the formula a plus b whole square, I get this is 10x square. This is a, and this 2 into a, which is 10x, 2 into a into b. B here is y, and I have b square, that is y square. So this is equal to 100x square plus 2 into 10, 20, 20xy plus y square. So from the digits of the two-digit number, you can find the square of a number, two-digit number. Okay. Now let's try to see some example. How can we find the square of a two-digit number? Let's say we are doing let's say 28 square. 28 square. So this will be equal to, now you can see that in this 28 x will be 2 and y will be 8. So if I apply the direct formula of this, so xy whole square is 100x square plus 20xy plus y square. So I have 100 into 2 square plus 20 into x is 2 and y is 8 and plus 8 square. So this is equal to 100 into 4, that is 400, plus 20 into 2 into 8 is 320 plus 64. So this is equal to 4 and then 8 and then 784. So let me quickly check if I am right or wrong. I'm using a calculator. So 28 multiplied by 28 is 784. Okay, fine. So in this way, you can find the square of a two-digit number using the formula a plus b whole square and the concept that any number xy, where x is the digit at the tens place and y is the digit at the units place, xy is will be 10x plus y. Let's try another example. Let's say 87 square. So this will be now. If you cannot remember this formula, that is xy, a number of the form xy, where a two-digit number xy, where x is the digit at the tens place and y is the digit at the units place, its square is 100x square plus 20xy plus y square. If you cannot remember it, then you can also break it down from the basic concepts. 87, you know, it will be 10 into 8 plus 7. If I expand it, this will be this. So now we apply the a plus b whole square formula. This will be 10 into 8 square, and then you have plus 2 into 10 into 8, and we have 7, because over here a is 10 into 8 and b is 7, and I have 7 square. Sorry, not a and b, x and y. So I was explaining the concept using x and y. The two-digit number is xy, where x is the digit at the tens place and y is the digit at the units place. Okay. So you can break it down, a given two-digit number, let's say 87, you can break it down, expand it as 10 into 8 plus 7. So then 10 into 8 will be x and 7 will be y. Then you apply the formula x plus y whole square. So you have this. Now 10 into 8 whole square is 100 into 8 square. Using the laws of exponents, I can write like this. Now plus I have 20, 2 into 10 into 8 into 7 is 20 into 56. 20 into 56 and I have 49. This is equals to 8 square is 64, so 6400 and plus this will be 612 1120 plus 49. So if you now add 6400 1120 and 49, we have 9657. So 7569 is the value of squaring of 87. So let me quickly check if I did it correctly or not. 7569 is the correct answer. Okay, fine. So I hope you got the idea of how to find the square of a two-digit number using the formula a plus b whole square, and using the concept that if a two-digit number, you first write it in the expanded form, that if the two-digit number is x y, where x is the digit at the tens place and y is the digit at the units place, then you can write the number as 10x plus y, and then you have 10x plus, to square the number you will have 10x plus y whole square, and then you apply the formula of a plus b whole square. This way you can also find the square of a given number. So this was method 2. The first method was column method. Method 3 is a special case where if you are given a number, if it ends with 5, the digit 5, then this concept will work. So the idea is that you are given any number which is ending with the digit 5. Okay. So any number ending with digit 5 is that the last digit, the digit at the units place, will of course be 5. Now whatever there could be the number could be 2-digit, 3-digit number, 4-digit number, 5-digit number. We don't know how many digits are there. So I am representing all the other digits as xx. Let's say whatever these other digits are, I am representing the number, if you accept the digit at the unit place as a. This is the idea. When in the notes you see the squaring number ending with a 5, let the number be a5, where a not equals to 0, where this a is not a single digit. It could be a 2-digit number, 3-digit number, 4-digit number, or 5-digit number. Whatever the original number is given, it must end with the digit 5. That is, the digit at the units place must be 5, and the number, and the number ignoring the digits at the units place, whatever the number is, that number I am considering as a. So we have the given number is of the form a5, where a is a number which could be a 1-digit, 2-digit, 3-digit, 4-digit. It could be of 1 or more than 1 digits. So we have to find a5 square. Now please note that what is a5? A5 is ultimately 10 into a plus 5. 10 into a plus 5, because you see, let's say the number is 125. This is a. So 125 we know we can write it as 120 plus 5. So this is equal to 10 into 12 plus 5. So this is equal to clearly 10a plus 5. Take another example, 925. 92, let's take a bigger number, 4765. So this is a. 476 is a, and we can clearly say that 4765 is nothing but 4760 plus 5. So this is 10 into 476 plus 5, this is equal to 10a plus 5. So we can say that if whatever the given number is, if it's the digit at the unit place is 5, then we can express it, write it in the form a5, where a is the number of the original number, but except the digit at the unit place. So if the number is of the form a5, then it will be actually mathematically, if I expand it, it will be 10a plus 5. So now I have, if a5 whole square is 10a plus 5 whole square. Now if I apply the formula of a plus b whole square, this becomes 10a square. In this expression, a is 10a and b is 5. So a square plus 2 into a, that is 10a, and b is 5, and again we have b square, that is 5 square. So this is equal to 100 a square, and over here we have got 2 into 10 into 5, that is 100a, and lastly we have got 5 square is equals to 25. Now from the first two terms, if I take 100a as common, I get 100a plus 1 plus 25. So this is the formula. This is the formula of finding the square of a given number where the number is ending with the digit 5, or the digit at the unit place is 5, and if you express that number in the form a5, where a is the number except a is the original number except the digit at the unit place, then the result is 100a multiplied by a plus 1 plus 25. So in the notes you will see some examples. You can see these examples. Let's say I want to find, let's say 225 square. This is a 3-digit number, and this concept will work for any number of digits. A number having any number of digits, but it must end with the digit 5. Now let's find what is 225 whole square. So I know what is the formula. 100. Try to understand the formula. 100 multiplied by the a. What is a? This is a. In the given number, you ignore the digits of the unit place, which is always be 5. I mean, this formula will work only for a number ending with the digit 5. So if you ignore the digit 5 ending 5, whatever the number is remaining, that is a. So this is a. A is 22. So 22, and then you multiply 22 plus 1, that is 23, and then you just add 25. So this is the formula, very simple. 100 into a plus 1 plus 25. Now you have to calculate what is 23 multiplied by 22. This is 46, this is 6, 10, 5. So I have 50600 plus 25. This is equal to 50625. So the square of 225 is 50625. Let me quickly check if I did it correctly or not. 50625 is the correct answer. Okay. So this is the basic formula of to find the square of a number where the number is ending with the digit 5. You can apply this concept. A will be the number, the given number, except the rightmost digit 5, that is the ending digit 5, and then the formula will be 100 into a plus 1 plus 25. Now let me quickly check if we can do a little bigger number or not. Let's say 1025. Let's say 1025 square. So the formula is 100 multiplied by what is a. A is this. Yeah, a is 102. A is 102. So 100 multiplied by a is 102, multiplied by a plus 1, that is 103, and then plus 25. Now you have to calculate what is 102 and multiplied by 103. This is 603 and this is 000 and this is 201. So this is 60501. So we have 1050,600 plus 25 and this is equal to 1050,625. So let me quickly check if the answer is correct or not. 1025 multiplied by 1025 is equal to 1050,625. Yeah, this is correct. So I hope you got the idea of how to find the square of a number where the number is ending with the digit 5 and the number could be of any number of digits. It could be single digits, two digits, 3 digits, 4 digits, like that. Okay, let's see what is the next. Now there are two interesting patterns in finding the square of some particular number. The first interesting pattern is if you the squaring of 1, 11, 111, then 1111. If you find the square in the notes, I can see it is written 111 cube. Sorry, it will all be square, and also 1111 it is written to the power 4. It is my mistake. They will all be square. So what is the concept? 1 square. So the idea is the interesting pattern is the interesting pattern is found in 1 square and then 2 1 whole square and then 3 1 square. We find an interesting pattern in these values and then 4 1 its square and so on. So what is the pattern we see? So given any number of ones, you can, if you know the concept, if you understand the pattern, you will be able to write the result. That is the squaring of any number of ones. A number squaring of a number where all the digits are 1. So the idea is, let's say, so 1 square is 1. What is 1 1? 2 1 its square is, all we know is that 1 to 1. Now 1 to 1. So what is the pattern? What is the pattern? So in 11 we have 2 digits. So you start with 1. And then you keep on writing the consecutive integers. So after 1 comes 2. But since 11 has only 2 digits, you stop at 2 and then you write the preceding numbers. You start writing the numbers in the reverse order. That is, you have written 1 2 and then you will write 1. So you will start from 1 and you will eventually end at 1. So let's say if we have 3 1 whole square, so there are 3 digits, 3 digits. So I will start with 1, 2, 3. I will stop at 3 because there are 3 ones. I will stop at 3 and then I will start writing the numbers backwards. So 2, 1. So let's say this way. Let's say I have 1, 1, 1, 1, 1. How many ones are there? 5 ones. So if I have to find the square of 5 1, that is 11,111. What will be the result? Since there are 5 ones, I will start writing from 1, 2, 3, 4, 5. I will stop at 5 since there are 5 ones, and then I will start again writing the numbers backwards. 4, 3, 2, 1. I hope you got the idea. For example, let's say 1, 1, 1 and 1, 1, 6. There are 6 ones. Okay, there are 6 ones. So definitely the value will be 1, 2, 3, 4, 5, 6. I will stop at 6 because there are 6 ones and then I will start writing the numbers backward. 5, 4, 3, 2, 1. So this is an interesting pattern in the value of a square of numbers where in the number all the digits are 1. and the value will depend on how many ones are there in the number. Okay, and the second interesting pattern is when you square the numbers like 7 square and then a single 6, a digit, a single 1 6, and then 7 square, and then 2 6, 2 6. All the numbers are ending with the 7, but and it is preceded by 1 or 2 or 3 or 4 or more number of 6, 6 6 7 square, and then 6 6 6 7 square. There is a pattern found in the values of these squares. So the pattern is like this: 7 square is, we know, 49, and 6 7 square will be, so in the 7 square it is 49. In the values of all these squares, all the values will end with the number 9. All will end with the number 9. What will be the remaining numbers? So the remaining numbers will be, if there is there will be so this 7 square is 49 and 67 whole square will be 4 4 8 9. So how come it is 4 4 8 9 and 67 square is 4 4 8 9 and 7 square is 49? So what is the pattern? What is the pattern? The pattern is that you see in 7 square there is no 6. There is no 6, but there is 1 4 and there is no 8. 49, in 49 there is only 1 4 and there is no 8. In 67 whole square there is 1 6. There is 1 6 and there are 2 4s. So 2 4s, and there is 1 8. 1 8 because there is 1 6. So the idea is, let's say, so I am explaining with 6 6 6 6 7 whole square. What will be the value? The value will always end with the number 9. Okay, fine. Now before 9 I will add I will add couple of 8s. How many 8s I will add? As many 6 are there in the given number. So we have 4 6. So I will add 4 8. And then before these 8 I will add 5 9, 5 4s, 5 4s. So the number of 4s will be 1 more than the number of 8s. And what is the number of 8? Number of 8 will be the number of 6. So this is the pattern. So so as you can see in the notes, I hope you can see the notes. Let me see if you can see the notes or not. No, you cannot see the notes. So now I hope you will be able to see the notes. Yes. So in the notes you can see the final. I will generalize the idea. So if 6 6 in the number, 6 is repeating n times. So n times, then that number, and it is of course ending with 7. The square of that number will be equal to, initially we will have 6 n plus 1 4s. Since there are n 6s in the given number, there will be n plus 1 4s, consecutive 4s, and then we will have n number of consecutive 8s, 8, and then finally it will end with 9. So this is the idea. So I hope you got the idea of you understood the interesting pattern of finding the squares of 7 and then 67 and then 667. That is a number ending with the digit 7 and preceded by one or two or more digits of 6. Okay. So that was all for this video, where we discussed about how do we square, find the square of a number. Mostly we have understood, we have discussed the column method, which works for a number of 2-digit number. How do we find the square of a 2-digit number using the 3 columns? Then we discussed how do we square how do we square uh, how do we square using the formula a plus b whole square of a two-digit number using the expanded form. So any two-digit number, if it is xy, where x is the digit at the tens place and y is the digit at the units place, then xy can be written in the expanded form as 10x plus y. So xy whole square will be 10x plus y whole square. And applying the formula a plus b whole square, we find that the square is coming out to be 100x square plus 20xy plus y square. So from the digits, from the two digits of the two-digit number, we can find the square of the number. The third method was how to find the square of any number that is ending with the digit 5. This also requires applying the concept of a plus b whole square. So the formula was any number ending with digit 5 can be written in the form a small a 5, where small a is the number if you ignore the last 5 digit 5. So the squaring of a5 whole square will be 100 into a plus 1 plus 25. And then finally we saw two interesting patterns. I hope this video was beneficial to you. If it is, please like it, share it with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos. But before that, please support me by subscribing to my channel if you are not yet subscribed, and if you are watching my videos and my videos are beneficial to you. The next section of the chapter will be finding the square roots. We will discuss about the different methods of finding square roots of a number. So stay tuned for the upcoming videos on the chapter of squares and square roots. So thanks for watching, and until the next video, take care and bye.